All right, so we're going to go into the digestive system, and most of you have already taken your lab test. This really does not need to be new information. It should be something you already know, and we're just adding to it. So we're going to add some more details of the stuff that you already know. If this is totally foreign to you, then you probably failed your lab test or will be failing your lab test today at 2 o'clock. Just being honest with you, okay? You should already know this stuff. Digestive system. Let's talk about digestion. We have organs that have food traveling through them, food or whatever it is we're digesting traveling through them, and that is the GI or the gastrointestinal tract. So imagine a tube that connects your mouth all the way to your anus, starting, with chewing the food, goes down the esophagus, the stomach, the intestines, small and large, and then leaving at the rectum. That is the main part of your digestive system. But we also have some other organs around it that aid in the digestive process, even though they don't actually have food traveling through them. And those are the accessory components of the system. And they're all in red on the slide. So the liver, the gallbladder, the pancreas, the salivary glands, the teeth and tongue, those are all things that are accessories to digestion, but the actual digestive process, whether it is chemical or mechanical, happens in those main organs in the GI tract. So everything in black here is what you'll see in the GI tract, things like the mouth, the duodenum, the colon, the appendix, all the stuff. I know, right? Okay, so the GI tract is a tube connecting your mouth to the rectum. If we travel through that tube, the parts of it that are named are the esophagus, and then it goes into the stomach. From the stomach, that goes into the small intestine, large intestine, and then finally leaves the body through the rectum. So we're going to take each one of these and those accessory components and break them all down and try to understand what their responsibility is as far as digestion. Okay? Our accessory structures to the GI tract are teeth, tongue, salivary glands, liver, gallbladder, and pancreas. The stuff, the organs that are around but don't actually absorb anything or don't have part in that one tube connecting top to bottom. Okay, so let's understand what digestion is before we can talk about who does the job. The very first step of digestion is ingestion. What is ingestion? Y'all know my ears are clogged, my head is stuffy, I can't hear a darn thing. Putting food in your mouth? Yeah, ingestion is putting anything in your mouth, whether it's a solid or a liquid. So anytime you eat something or drink something, you are ingesting it. And that is the first step of digestion. And then we have secretion. So we have glands or glands embedded within an organ that are meant to secrete things, whether it's something like a substance like saliva, or maybe it's a hormone, maybe it is an enzyme. So all sorts of parts of the system will be secreting things to aid in digestion. So anytime you see something that has a secretion, that is that secretion part that we're talking about. A very good example of that would be your salivary glands, because they are secreting saliva. Right? Your stomach is secreting hydrochloric acid, among other stuff. Then we have motility. So after you eat the stuff and you throw some saliva on it or enzymes on it, then you got to mix it all up. And that is motility. So the entire GI tract involves movement. Everything has to be moved around. Even in your mouth, you do have to move the food around with the saliva as you're breaking it down, and that's where digestion actually begins. So motility is huge. Then we go through digestion, and the actual word digestion means to take something that is large and break it down into smaller pieces. And that can happen mechanically or chemically. An example of mechanical digestion is when you chew something. Right? Your teeth are physically grinding it down into smaller particles. An example of a chemical digestion is when that enzyme, salivary amylase, that comes out with your saliva begins to break down the sugars in the food that you eat. That is a chemical digestion. It actually takes a large sugar, a polysaccharide, and breaks it into smaller sugars. Okay? So that is digestion. Taking something big and then adding an enzyme or an acid or whatever, making it something small. And that's chemical is what's displayed here. Mechanical would be the example that I told you about. Then we go into absorption, and this is the stuff, the time where you take all of the good stuff that you want from what you just ate and drank and put it into your bloodstream. So we're actually absorbing it into our bloodstream, whether it's sugar or fat or whatever your body needs. And then at the end, all of the waste products, which will become feces. Feces means poop, is defecation, or can also be called elimination. So at the end of the day, I have eaten, or I have, what's the right word? Drank, drunken. I drank. I eat and I drank. I eat and I drank. I break it down, mix it all up, right? Absorb the good stuff, and then at the end, I get rid of everything I don't need, okay? So that is the entire process of digestion. It starts with ingestion, goes to secretion. We got to throw stuff at it. Motility, we got to mix it up with the stuff that we threw at it. Digestion, that stuff that we threw at it with the mixing is going to break it down into smaller pieces. Absorb the stuff you want, eliminate the stuff that you don't need. Cool? All right. Here's that slide that if you don't know this and you haven't taken your test yet, you need to go home and don't come back. Layers of the GIT. Layers of the gastrointestinal tract. You already know this by heart, right? Mucosa, submucosa, muscularis, and then on the very outside is serosa. Let's talk about some details of those layers because we didn't really break them down too much. We knew that the mucosa had 3 layers, the epithelium, the lamina propria, and the muscularis mucosae, right? But we didn't talk about why it had those layers. So epithelium, that is your protective layer. That's your very top layer that's exposed to the outside. So with the epithelium in our GIT, we are going to protect this tract that has things moving through it. We are going to secrete from the glands that lie below it, and we are going to absorb from the stuff that we have digested. Then your lamina propria, that's where you're going to find your blood vessels and your lymphatics. Your muscularis mucosae, remember that was the tiny, tiny little muscular layer, and at the time I told you it's not strong enough to create movement. But what it does do is it can create little creases or folds in that mucosa, and that gives you more surface area. Does everyone understand the idea of having creases or folds giving you more surface area? Maybe? No? Yes? Do we understand that concept? Okay. Okay, then we had the submucosa, which at the time we said was just connective tissue, some blood, and lymphatics, but there is a nervous component in the submucosa that is actually important, and that is the submucosal plexus. So the submucosal plexus is part of the autonomic nervous system, and we're going to talk about it in a little bit about exactly what it does, but the submucosal plexus actually controls the secretion of those glands. In addition to that, this is where you're going to find those parasympathetic ganglia. Remember when we talked about the parasympathetic system, we said the ganglia are terminal ganglia found in the organ or in the wall of the organ or very close to it. Most of the time they're found in these submucosas where you find your parasympathetic ganglia. Then we have our thick muscle layer, that muscularis. All right, so the muscularis in the GI tract could be skeletal muscle or smooth muscle. When it is skeletal muscle, that makes it a voluntary muscular layer. So skeletal muscle is voluntary. Smooth muscle is involuntary. Now, where can we find this voluntary skeletal muscle? Well, places like the mouth, the pharynx, and even the upper 2/3, although it's really mainly the upper 1/3. But the top part of your esophagus also has skeletal muscles. So your tongue, we can actually chew and move things around purposefully. That is skeletal muscle. Then once you get to about midway of the esophagus on down, it is all smooth muscle. We have no control over it. So what does control it? Well, we have a portion of the autonomic nervous system, the myenteric plexus, found in that muscularis layer, and that's what controls smooth muscle contraction or relaxation. Then, and we are going to break these down quite a bit, so don't worry, because when we take each organ, we're going to talk about the mucosa, we're going to talk about the muscularis, we're going to take specifics per organ. This is just an overview for now. Then we had that serosa, which was your outermost layer. And remember, in the esophagus, that serosa, it wasn't serosa, it was adventitia, right? It was just connective tissue covering the esophagus. Once you went below the diaphragm, I told you that everything in the abdomen is covered, except for the kidney, covered in peritoneum, which is serosa, right? Or serosa is, the peritoneum is part of the serosa, if that makes sense. Okay. So visceral peritoneum when it's on the organs, and then adventitia in the esophagus, and of course the parietal peritoneum was on the abdominal wall. A lot of, oh, you guys haven't taken it. Who hasn't taken the test yet? No? Okay. Just saying. Y'all, I've had some of the lowest test grades on this test. I don't know what's going on because I didn't like make it harder. It's the same difficulty level it's always been. And then, you know, it's funny because like y'all had all a spring break. You had 2 weeks to do the slides. I think the slides got more people than the dissection. The dissection was no problem. But I've seen so many strange answers. Like, okay. Well, things like, you know, you call like a slide of intestine and you call it esophagus, yet you know what a villus is. It's the same darn slide. I didn't change the slide. All 3 questions are on the same thing. So why are you putting a villus in the stomach? Or why are you putting a liver lobule in the pancreas? I just don't get it. I don't get it, really. I've actually questioned, like I've seen some answers that have made me question, do I need to go back to basics and just give you like a chart of the human body like they did in like 2nd grade and be like stomach, liver, spleen? Because I don't know what y'all smoking, but it ain't right. Okay, moving on. I'm just shocked at the answers I'm getting. Okay, I don't know, and it's like, I've got everything grouped together, but I'm gonna let it go. All right, so innervation of the GI tract, we have something called the enteric nervous system. The enteric nervous system is controlled by the autonomic nervous system. So it is basically the autonomic nervous system, but found in the gut, okay? And it's found, or it's subdivided into 2 plexuses in particular, the submucosal plexus and the myenteric plexus. Where is the submucosal plexus? In the submucosa. Thank you. Right, submucosal plexus is in the submucosa. Well, what does it do? Well, that's where we found a lot of the secretory parts of these organs. So that is where it is going to control the secretion from those glands. So submucosal, look, it's S. Submucosal controls secretions. What about the myenteric plexus? Where was that? That was in the muscularis. So myenteric plexus, muscularis controls muscles, so that is motility. All right, can we just keep the S's with the S's and the N's with the N's and call it a day? So that means myenteric plexus is controlling all of my smooth muscle that is in the GI tract. The submucosal plexus is controlling all of the secretions from those glands. And that is found in the submucosa. Okay. Both of those plexuses together make up the enteric nervous system. And that enteric nervous system is controlled by this guy right here, the autonomic nervous system. Well, how does it do that? Or what does it do? The parasympathetic division is going to do what to motility and secretions that have to do with digestion? What is the parasympathetic system? It's rest and digest, right? So the parasympathetic system is going to increase all of my digestive functions, secretions, and motility by activating that enteric nervous system. The parasympathetic was the sympathetic was the opposite, right? That was fight or flight. You didn't need to be eating anything or digesting anything. So that is going to inhibit that enteric nervous system, decreasing all of the secretions and motility. Okay? Like I said, this should be a review. This should not be, we're only adding little bits of new information. The rest should all be stuff we know. All right, let's talk about how it does that, because we know that we know how the autonomic nervous system works, right? We know that we have sensors or receptors throughout our body, inside and outside, and they take in information and they take it to the brain, right? Or hypothalamus, or wherever it needs to go, thalamus if it's somatic sensations, and then decisions are made. But we also learned when we did the nervous system that there are reflexes that happen at the level of the spinal cord, right? Sometimes things can be taken care of immediately. So let's talk about how those work in relation to the GIT. And we're going to start down here where it says the sensory neurons. So these are sensory receptors, whether they're chemoreceptors, and there's some type of interoceptors, okay? Something on the inside, in your gut. Let's say this is the one that's in my stomach that gives my mind an idea or a reading of how full my stomach is, okay? So let's say I am, do we want our stomach to be empty or full? Full. Okay, so I just had a really nice lunch and my stomach is full. So these interoceptors here on that sensory neuron will sense that the stomach is distended, it is full. And then what does it do? Well, its job is to send that up to the central nervous system, right? Okay, at the same time, it is also going to send that same impulse to the submucosal plexus and the myenteric plexus, because this is something that needs to get moving immediately. So it goes to the myenteric plexus. The myenteric plexus says, okay, stomach is full. We need to make sure we're mixing it properly. Let's get those muscles moving. Sends that impulse down and says, hey, move your muscles, stomach. We got to start churning this food. It also goes to the submucosal plexus. Submucosal plexus says, okay, the stomach is full. We just had McDonald's, lots of fat. We need a lot of acid to break this down. Start producing acid glands, start secreting all of that hydrochloric acid. And so it goes to the stomach and causes it to secrete that hydrochloric acid. Get what's happening here? So while this sensory neuron here is carrying a sensation to the brain of, oh my gosh, I'm so full and happy, or I'm so full, I'm going to explode, whatever it is, or why did I eat that? Why didn't I eat a salad instead? It is also sending it to the myenteric and the submucosal plexus so that they can do their job, okay? And that is why it is considered a reflex, because it can actually act on its own and go back and cause something to happen. Even though it's sending it to the brain, it can still do it on its own. So the point of this whole reflex, or the idea behind it, is that those sensory neurons that are carrying those impulses coming in from your gut have the ability to set things in motion. What goes to your brain or your higher centers is more about how we feel about it or comprehending what we just did. Okay, maybe remembering it. You had a piece of cake and it was super yummy. You want to send that to your brain so you remember the next time you want cake, you want that same kind of cake, right? Or maybe it was really gross and you never want to eat that again. So then we have to go and associate that with feelings of gross. I don't want to have that again. I never want to put that in my mouth another time, right? But the actual movement and things that need to be done get done at this level over here as far as physical changes. Whew. All right, let's talk about peritoneum. So if you imagine a body with all of these organs sitting in this abdomen, and they're all secreting juice and acid and producing feces, and there's bacteria, there's all sorts of stuff happening in your gut. We're not very picky about what we put into our mouths, right? So you kind of want to keep that stuff isolated from the rest of your body, right? Not only that, but you got a lot of movement. Remember, one of the main steps of digestion is motility. So if you can't mix stuff around, you're not going to be able to digest it. So we've got things that are gross on the inside and some dangerous, things like protein-breaking enzymes and acid, and we have movement. So everything in this compartment is covered and separated, and they are all covered by peritoneum. So imagine this. If this is, I'm looking at a side image here, and this is the liver, and right here, this is the stomach, right? And I am going to wrap all of this in that protective saran wrap called peritoneum. I start at the diaphragm at the very top, and I do the front of the liver, and then I'm going to do the bottom of the liver, and then I hit the wall here. I have to go back to do the stomach. Do you see what's happening here? And then I would go back and do a part of the intestine, and then another part of intestine. So what I've created here are places in between these organs where that peritoneum folds on itself. Something like right there, in between the liver and the stomach, right? Those peritoneal folds, I forgot what I was going to say. Did y'all see that commercial about Alzheimer's that's on TV lately? Yeah, that scared me. Yeah, I know. And they're like, well, Grandpa's forgetting what he's saying mid-sentence. Like, oh, no. Okay. Bring it back. What? On your kids? Well, I haven't, like, my last pregnancy was 16 years ago. I can't blame it on mom brain anymore. I can't. Anyways, okay, so we have these peritoneal folds. Oh, I remember. Okay, so those peritoneal folds, not only, they're just not like a consequence of because we did that and we had to go back, they also help attach these organs. They help keep them in place in relation to each other, okay? And we've already seen some of those folds. This one right here, between the liver and the stomach, that is the lesser omentum. That's a peritoneal fold. Okay, so, and we're gonna see that on the next slide. Parietal peritoneum is the peritoneum that's covering that abdominal wall. Visceral is the one that covers your organs. Now, when I have completed the wrapping of all of these organs and the abdominal wall, I have a completely enclosed space. And that space is called the peritoneal cavity, okay? So the area, it's kind of like thinking, okay, your entire abdomen wall, front and back, is covered in peritoneum, but so are those organs. And there's no opening in this cavity. It is a closed space. And the point of that is, if you have an intestine or a stomach that's perforated and leaking acid or leaking feces into this bacteria, into this cavity, you can contain it. You're not going to infect your heart or your lungs because they're completely separated from everything else. Okay, so that is what we call the peritoneal cavity. Let's talk about those spaces where it folds over itself. That greater omentum, that big fat yellow bib of fat in the front, that actually is a fold of peritoneum. The lesser omentum is a fold of peritoneum. Remember the one between the stomach and the liver? There's also a falciform ligament right here between the two lobes of the liver. So you covered one lobe, came in, and then hit a dead end and had to go back. So that formed the falciform ligament. The lesser omentum we talked about, the mesentery over all of the small intestine, that is peritoneum, the peritoneal fold. And there's also a mesocolon on the colon, the large intestine, that is a peritoneal fold. So those are the folds of peritoneum. They are important because they help keep the stomach from riding up over the liver. They help keep the intestines from getting all tangled up with each other. So these folds are actually important because they help stabilize all of these organs inside of your abdomen. Remember, there's a lot of movement happening here, and you don't want to strangle anything or get caught in a space that's too tight. All right, do I have any questions so far? It's pretty easy, right? This is a nice light day to have after testing. Okay, so let's begin the journey of digestion, and it starts where we stick all the stuff in our mouth and what happens to it. So let's talk about the anatomy of the mouth. We've got a lot of this you already know. You got teeth, you got gums, you have a hard palate, a soft palate, you have a tongue, you have space here that's called the vestibule, sorry, a lingual frenulum. You have the little, the thing that the dangly, the dangly in the back of my throat. Y'all know what I'm talking about. Right here, the little dangly thing in the back of your throat, that is called the uvula. Uvula, okay? All you dirty minds. It's a little dangly thing at the back of my throat. Okay. All right, that's the uvula. And the uvula actually does serve an important purpose, and it's not to make you gag and puke. The uvula is meant to push up when you swallow and close off your nasal cavity, because your nose at the very back is open to your mouth. And yes, that is why when you puke really hard, it can go out of your nose. Absolutely. Just saying. Okay. We also have salivary glands that aren't actually inside the mouth. They're outside, but they do open into the mouth because they produce saliva, and saliva is going to serve a very important role in digestion. And we have 3 pairs. When it says pairs, yes, that means you have one on the right and one on the left. Okay, they're not next to each other. They're on either side. So we got 2 parotid glands, right, on the outside. Y'all should know that already. 2 submandibular glands, those are below the mandible, and 2 sublingual glands below the tongue. So all of those, and there are some other areas that have smaller salivary glands, but we're not going to worry about those. There's places on the lips, there's places on the tongue that also have the ability to produce saliva. But these are the main 3 that we're going to talk about. So they are producing saliva, which is not just a watery, lubricating substance to help you moisten and chew up your food. It also contains enzymes that will begin that actual breakdown or digestion inside of the mouth. And there is a condition known as xerostomia. You may call it dry mouth. The medical term for that is xerostomia. That is the insufficiency of saliva. So if you're not producing enough or not producing, if you're not producing enough saliva or have a deficiency of saliva, it's called xerostomia. Yes. Somebody asked me if xerostomia causes bad breath. Yes, it does. Then ask me why. Because if you remember in A&P1, I hate to be like the nagging mother. Do you remember A&P1? Okay, in A&P1, remember we talked about saliva and we said that it has antibacterial properties, and saliva not only aids in digestion, but it is meant to wash your mouth of bacteria, because we're constantly, especially if you're me with your mouth constantly doing this, we're letting a whole bunch of stuff inside. And so saliva is supposed to be produced regularly to wash away all of that, and then you swallow it and let the acid in your stomach take care of it. Kind of like the way our tears work too. And so if you don't have any saliva, or you don't have enough to wash all that bacteria away, yes, you do end up with accumulation of bacteria in the mouth and bad breath. Then somebody say, well, there's a term for bad breath, right? Yes, it is halitosis. That's right. Not that this is like, yeah, this is just for your knowledge. This is just the interesting stuff that my other students thought to ask that nobody in here has thought to ask yet. Because y'all figured out if we don't stall her, we'll be out of here quicker. I get it. You know everything already? Oh, all right. So we have, we also have a tongue. Yes, a tongue. What does the tongue do? Well, the tongue serves a very important role in digestion because it's going to help us chew stuff, right? It's going to help move things around so that the teeth can grind them down into smaller particles. It's going to aid in swallowing. How does it do that? Well, after you've chewed up all that food and mixed it with saliva, it makes it into a little ball and helps you push it to the back of your mouth. And yes, we do use it to talk. I know, right? And on top of all of that, there are places on the tongue that have papillae, which are those bumps, and a certain group of papillae will actually have taste buds, which we already know are the taste receptors, right? Hopefully, because you've already been tested on that. Okay, then we got our teeth. So our teeth also play in a role in digestion, not chemical, but mechanical digestion, because they will mechanically break down things. So aided by the tongue, they can break all of the foods that we take in into smaller particles. Just a quick overview of what makes up a tooth. Above the surface right here, you've got the crown. That's the part that's above the gum line. The neck is the junction. And then the root is everything that's down below the surface, embedded in the bone that you don't see. The crown is covered in enamel. That is the white, pretty stuff that everybody's trying to bleach all the time. Below that enamel, below the enamel is the dentin, and that's sort of like the ground substance of your teeth. Inside the root here, you'll notice that there are canals. You see these empty spaces? Yes, there is an empty space, and in that empty space is where you get your blood vessels, the arterioles, the capillaries, and also the nerves. So yes, this is the part that they open up if you're doing a root canal, right? So in a root canal, they actually will drill a hole, come in here, and then get little tiny like files. They're almost exactly like wood files or even like a nail file, but it's a round rod, and stick it into these roots here to obliterate the nerve. Yeah. And then this also brings to mind, there was a question yesterday, is it like this, like the villi where you have a capillary in one and then a nerve in the other? No, there's nerves in both of those roots, or however many roots this tooth has, there will be a nerve in each root. So that is a root canal. Why do we do root canals? Well, if you have a cavity, just one reason, if you have a cavity here that eats away that dentin, eats away the enamel and the dentin, it will expose this nerve. And an exposed nerve is a very painful nerve. Very painful, very irritated. So we do root canals to save you from the pain. Come in, kill the nerve, remove it, you no longer feel pain. And then someone has to say, well, why wouldn't I just pull the tooth? Why wouldn't you just pull the tooth? And by the way, cavities are not the only reason. It could be a cavity that turned into an abscess. There's lots of reasons that you might need a root canal, but the end result is the nerve has somehow become exposed. Why would you not just pull the tooth? Because what? You need it? No, I've never heard that one. Yeah, you kind of do. Yeah. But, and it's not just because your dentist needs you to pay that $800 for a crown. There's other reasons other than that supporting your dentist lifestyle. let's just circle back to AP1 again. Talking about bone. Remember, this is bone here, right? This is bone. And what did we learn about bone? We learned that bone is constantly being reabsorbed, right? And remineralized. We're always forming new bone. That's why we shrink as we get older, because we're breaking down the bone, but we're not as quick at building it back up. But when you're, when you're still growing, you're still breaking it down, but you're building it faster. And then when you become fully grown as an adult, you should be stable. You're still breaking it down because you need those minerals, and you're still redepositing it. But the point is that our bone is constantly forming and reforming and reforming. If I take this tooth out completely, I have now left a gap here. And when that bone begins to form and reform, the teeth on the other sides are going to end up moving in or moving around in order to fill this gap. Yes, so your teeth will shift. And then if your teeth shift, you could end up with an abnormal bite. If you end up with an abnormal bite, then you're going to go into things like TMJ, and it's just a nightmare. So if you do ever have to pull a tooth, you want to make sure that you put something in its place to keep all of the other teeth in their place, so nobody tries to move around and cause any other problems. You're welcome. Okay. My little bits of me. Okay. So those are the main structures in the mouth: the teeth, the tongue, and then we had the salivary glands that were outside the mouth but contributed to digestion. So let's talk about how they do this digestion. Remember, we have two forms. We've got mechanical digestion and chemical digestion. Mechanically, how am I digesting in the mouth? Well, I'm chewing the food, right? I'm physically breaking down that carrot that I just took a bite of into tiny, smaller pieces so that I can digest them chemically later. So yes, chewing is your mechanical digestion that happens. When you do chew, you're going to mix all that with the saliva, make it nice and moist and mushy. And then the tongue is going to aid in forming a little ball, and that little ball is called a bolus. Okay, it's like making little bite-sized, chewed-up morsels, kind of like if you've ever seen a bird feed its kids, right, where it chews it up and then regurgitates it. They're regurgitating all of these little, it makes a bolus and gives it back to it, to the little baby bird. I don't even know what a baby bird is called. Chick? Anyone know? No? Okay. I'm not crazy about birds anyways. I used to breed birds, and now I'm terrified. If y'all want to know, I'm going to give you a piece of my life here. That is my one irrational phobia, birds. Yes. That is the one thing that will make me run and scream in the opposite direction. I don't care about snakes. For real. It is completely irrational. I cannot be around. Something about the flapping wings. But even the ducks that are out here, those are evil ducks. Have you seen what they look like? Yeah. Those are like ducks straight from hell. For real. They're not friendly. I just don't like, I can't be around birds. And it's crazy because there's pictures of me at 11 years old with like a parakeet on my shoulder and what was the other one? The bigger one with the gray and the yellow and the orange. Not a parrot. In between a parakeet, parakeets are small, cockatoo or cockatails. I used to breed cockatails. Like I had them, they had eggs, they hatched, and I gave them away. Yes, and I am dead terrified of birds. I don't know when it happened. I have no idea. For real, I probably need to undergo like hypnosis or something to find out, because I am so terrified of them. I've watched a lot of movies, but I don't remember movies, but I'm just something about the wings flapping that get me, and that's what a phobia is. It doesn't have to be explained because it's a phobia. That is my one phobia. I mean, I could have like spiders crawling on me and a snake on my shoulder and be okay, but don't put a bird anywhere near me. Anyways, so that's mechanical digestion. Let's talk about chemical digestion. I don't know how that went to birds. We have two enzymes that are being secreted in the mouth from those salivary glands. We have a salivary amylase and a lingual lipase. Okay, salivary amylase, lingual lipase. Both of them are coming from salivary glands. What does salivary amylase do? It breaks down sugars. More specifically, it takes your polysaccharides and turns them into disaccharides. What does lingual lipase do? Well, it breaks down fats. So it is going to help break down the triglycerides. Those are the fats. So salivary amylase are sugars, and lingual lipase is fat. Now, here's the deal. Have you ever gone and gotten like a thing of fries from McDonald's and then had to rush into class and come back after class? It's in your car. It's really not hot anymore. Now they're kind of cold fries, but you're starving. And you have a few cold fries, and then all of a sudden you feel like there's this like fat layer on the inside of your mouth. I do it all the time. I feel this feeling all the time. I'm going to tell you why. Okay, salivary amylase breaks down sugar, secreted into your mouth by the salivary glands. It is active in your mouth. It is actively breaking down sugars right there in the mouth. When it hits the acid of your stomach, it's no longer active. It's inactivated by stomach acid. Lingual lipase, the one that helps break down the fats, is the opposite. It's secreted in the mouth. So you have lingual lipase in your mouth, but it is inactive. It doesn't become active until it reaches the acid of your stomach. So lingual lipase is activated by the acid in your stomach. Okay? That's why, or at least in my head, I've convinced myself that that is why when you eat a cold French fry that's full of grease, you end up with that gross, waxy feeling in your mouth. Okay? It's not really why, but I like to remember it that way. Huh? When you eat. Yeah, there's a lot of things that do that to me. For the longest time, I couldn't have, like, I can't drink black tea because something about black tea, I can if I'm at home because I can brush my teeth, but right after I have tea, I feel like there's this weird coating of something on my mouth. But I'm not a normal person, so. Okay, so there's our first two enzymes that we've looked at. One of them that does sugar is active in the stomach, active in the mouth, inactivated by stomach acid, and then lingual lipase is inactive in the mouth, activated by stomach acid. Am I going past time? No. Okay. Well, Erica was just staring at the clock. And the rest of these are just. Is that really what y'all picked to? There's 2 clocks in the room, and neither one of them has the right time. And that's the least of my worries. Why are there 2 clocks in here? See, that one is 20 minutes ahead, so it makes me happy. That one just doesn't move off at 9 o'clock, so it makes y'all miserable because time never ends in here, right? It just stays still. All right, so summary pages, you guys can look over the summary pages on your own if you want to. If not, that's fine also. Let's go right into the pharynx. Y'all ready? All right, funnel-shaped tube. Click. From the internal nares, this is the internal nares, it's the back of your nose. And over here, that's the back of your mouth. To the esophagus, which is this tube right here. Okay? There is your pharynx. There are 3 regions to the pharynx. It's not written. There is the nasopharynx right here. Oropharynx behind the mouth. Laryngopharynx across from the larynx. Okay? 3 regions of the pharynx. Why do we care about a pharynx? Because it is a common area between your nose, the back of your nose, the back of your mouth, and your breathing tube, the trachea. Okay? So that means that I have 3 things. 2 of them I breathe from, 1 I swallow from, and they're all open to each other. Okay? Like the mouth is supposed to go to the esophagus. Yes. And the nose is supposed to go to the trachea. Yes. In reality, it's one big space and you got two holes at the bottom. Yeah. Okay. This is why you vomit from your nose and you choke on things when you try to laugh or talk while you're eating. So that is the pharynx. It is skeletal muscle, meaning it's voluntarily controlled somehow. So let's talk about these openings, because right here, this is the esophagus here. This is where I want my food to go into, okay? Right here, this is the trachea. No food should go in there. Up here, this is your nose. No food should go in there. So there are things in place to close up those openings when you are swallowing food or drink. Over here, you can barely see it, but there is a uvula that's meant to block this. That's the little dangly thing that's swinging in the back of your throat. Down below, the flap that was on the trachea, that is your epiglottis right here. That is meant to fold over and close the trachea. So now when I swallow, it should, the tongue here is huge, but it should go right down the esophagus because I've closed up above with the uvula, I've closed down below with the epiglottis. Everything's meant to go in to the esophagus when I'm swallowing, and then when I'm breathing, they'll open back up again. Any questions on that idea? No? Okay. So now you know the answer to why is it when I'm drinking something and then I laugh really hard, it can come out of my nose, right? Okay. Why is it when I'm trying to eat a cookie and talk at the same time, I can choke? This is why. Okay? Cool. All right. Oh, also why is it when I have allergies, I'm coughing? Anybody ever think of that? Postnasal drip. Yeah, what is postnasal drip? Right here, you got mucus and junk. It's dripping like a leaky faucet. Drip, drip, drip. That irritates this, makes you cough. It's all good information, all good stuff. All right, the esophagus. I had some students that couldn't identify the esophagus on dissection. Y'all kidding me? Really? Yes. Not good. Okay, the muscular tube that's behind the trachea that connects that pharynx to your stomach, your layers of the esophagus, mucosa, submucosa is not written, and then muscularis. Obviously, submucosa is not written because there ain't much going on there. The mucosa here is stratified squamous epithelium. It's a huge layer because this is an area of high traffic. I need a barrier. I don't need to absorb anything because I'm really just beginning digestion of sugars in the mouth, but I'm not absorbing anything from the esophagus. It's basically just a tube to get us safely out of the chest and into the abdomen. Then you have the muscularis. And remember the slide of the esophagus where you had two very distinct muscle layers in the muscularis of the esophagus? Yes. So we have muscles that go in a circular fashion all the way around the esophagus, around that opening or the tube. And then we have longitudinal muscles that go up and down. In addition to that, the superior superior top third of the esophagus is skeletal muscle. The inferior 1/3 is smooth muscle, and then the stuff in the middle is mixed. So top third is skeletal, lower third is smooth, the middle is mixed. So that tells me that I do actually have a little bit of participation in that swallowing down your throat motion, right? Okay. I also have sphincters that control things coming into the esophagus and leaving the esophagus. So at the top is the upper esophageal sphincter. You may see it referred to as UES. The upper esophageal sphincter is skeletal muscle. It is a voluntary sphincter. We do voluntarily open that up to swallow. Okay? This is why you can't force. Huh? Yeah, but that's why you can't force your kids to take medicine, right? The lower esophageal sphincter is involuntary. That is at the very bottom. It opens the esophagus up onto the stomach, right? Okay. So what's going on in the stomach? It's like bubbling lava of hydrochloric acid. And this guy right here, lower esophageal sphincter, his job is to keep that nice and closed and tight, like holding the gates to hell closed. And then when something comes down, it opens up, lets it in, and then closes back up again. Let's talk about what happens when it can't close. Like, what if it's weak? What if the stomach is too full? What if the stomach is so full that this sphincter can't close? Kind of like, have you ever tried to close a trash bag in the kitchen? I do it every day, where, you know, I've crammed so much in there and I try to close it really hard, but I can't. It's still got a little bit of it open, you know, because it's just too full. Well, that can happen with your stomach. If your stomach is over full and that lower esophageal sphincter is trying to close, it may not be able to if it's too distended. So then what happens? Well, you've got this bubbling, I think of it as lava or the gates of hell, but you got this bubbling acid in the stomach. And what happens is it's going to jump up into the esophagus. And when it does that, it's going to irritate all of that. That's what you call heartburn. Yes, sir. Nothing. This is GERD. This is what I'm talking about right here. What I just explained to you, it happens in the beginning. We're calling it acid reflux. Okay, because now I have acid going into the esophagus. Let's say this happens for years. It's now habitual. Now we can call it GERD.
Okay, so what's just chronic definition?
Yes, yes. So acid reflux is a symptom. GERD is a disease. Oh, it can. Sorry. Yes, it can. It can do some major damage in this esophagus. No, there's lots of reasons it can happen. There's lots of reasons it can happen. It doesn't have to be just because you overate. I just use that as an example because it's easy to visualize a stomach that is so full that you can't close it. But no, absolutely not. Sometimes it happens. Sometimes it's just hereditary. Sometimes you somebody who's like never eats more than like a bird and still has it. So yes, absolutely can happen. Not only that, but you've also got, playing in this field, are psychological things like stress. You have hormones. You have genetics. You've got a lot of other things that can play a role in it. Yes. So it's not just from overeating. But it is all because this guy here can't contain what's going on in the stomach, right? So, Spray does it to you? Sprite. Oh, okay, yeah. So that is acid reflux, and we call that GERD, G-E-R-D. GERD stands for gastroesophageal reflux disease. Okay? Do I need to write that out? Gastroesophageal reflux disease? No? Okay. So yeah, that's why I think the esophagus is cool, because this is something that happens fairly common. So this is one of those things that happens to my boys, for some reason, think they're the kind of kids who, like, we go to an Indian restaurant, they want it Indian hot. And I'm over there shaking my head going, dude, do you know what you're doing to your system? Okay? Yeah, spicy food, what makes it spicy, those peppers that make our food spicy, it's that spicy feeling is actually a painful stimulus. That is physically hurting the inside, the mucosa of your GIT. It is physically injuring it. And so they will do that. And I sit back, I'm like, okay. And I roll my eyes. And then as soon as we get home, oh my God, where's the, I need a Zantac. I'm like, what? No, you don't. Like, nope, go find a Tums. You're not taking Zantac. I don't even allow Zantac in my home, right? They have to bring it over from their dads because I won't keep that stuff in my house. So what's the difference between Zantac and an antacid? Like Tums. Anybody ever think about it? So there's a reason it tastes so bad, Tums and all those other things, because that chalky taste, right? When you chew those things, or maybe it's like, what is the other one? Mylanta, Rolaids, all that stuff. It acts to neutralize the acid as a buffer inside of your stomach. Okay, it's not something you're absorbing into your bloodstream. It's acting locally at the level of the stomach. So if you have a little bit of heartburn, because for some reason maybe you had a big meal or you irritated your stomach or whatever, you take that, it's going to help neutralize the acid locally. It's just like you're doing a science experiment where you have a strong acid and then you take a weak base and you throw it on there, right? Buffers. When you take something like Zantac, which they're so proud of now, they're like now available without prescription. It should have never been available without a prescription because those are hydrogen blockers. They actually prevent your stomach from producing that acid. Okay? Yeah. Yep. So instead of just calming the pot by neutralizing the acid that's there, now you're going to the source of that acid and trying to prevent it from working. Yeah. And what does our body like to do when we stop it from doing something? Or not? We haven't talked about this before. Okay, so let's say I let him take the Zantac. He takes it. Now his stomach is preventing production of acid for a period of 6 to 12 hours, however long it takes his liver to detoxify that Zantac pill. He's not producing acid or very low amounts of acid. By the time he has his next meal, okay, which could be 4 or 5 hours later, he's still not producing acid. Let's say he eats something that has a lot of fat in it. An hour later, he's like, oh my God, I'm going to die because now the Zantac is wearing off, right? And the minute it wears off, it's going to up that production immediately. Now the stomach has to produce more acid to make up for the period that it couldn't produce any. So now you have heartburn again. And then you go pick up another Zantac, take it again, do the whole cycle over and over. And that's why I won't let him do it. Does this mean you should never take a Zantac? No, it just means that that's not meant for occasional heartburn, right? Now, there are situations where somebody has a chronic condition or something out of their hands where they can't control it by diet or exercise or reducing stress. Maybe you really do have something that needs or you're overproducing acid. Absolutely, that's when you need it. But my 16-year-old cannot make that decision just because he had heartburn. It's not like you're taking, you know, an aspirin, oh, I got a headache. No, you really need to think about it before you start putting yourself in that cycle. So anyways, that was my spiel about, and that happens a lot. You'll see it a lot now because, like, I went to lunch. I don't think we're doing anything after that. Yeah, we'll stop there. I went to lunch the other day with my friend, and she was like, it was a late afternoon lunch, like 4 o'clock, and she's so congested. I'm like, oh my gosh, are you okay? Are you getting sick? Oh no, it's just because I'm an Afrin addict. Yeah, and she's right. It's true. Yeah, it's true. Because if she stops, she takes the Afrin every morning, sprays it into her nose. Afrin's a decongestant, right? And then you get a rebound. So now we're making up for it. And that happens with lots of stuff. But anyway, so don't be swallowing no Zantac unless your doctor told you you should be on it.